water is split into hydrogen and oxygen by electrolysis. But if CO2 is also added to the mixture, compounds can be generated to make textiles, diapers, and even spirits. A team of researchers from Canada and the US has developed a catalyst that quickly and efficiently converts carbon dioxide into simple chemicals. In this way, they transform the most important greenhouse gas into useful products. The technology of water electrolyzers is well known. They transform water and electricity into hydrogen and oxygen. But in this research, the scientists add CO2 to the cocktail, and instead of producing hydrogen, they can generate various hydrocarbons such as ethylene, which is the most widely used organic compound worldwide. That is, it helps to obtain raw materials for the manufacture of products such as construction materials, textiles, paints, electronic device components, diapers, or even spirits. The key to the new device is a polymer coating that facilitates the transport of CO2 through the surface of the metal or electrode of the catalyst. Carbon dioxide, generally speaking, has difficulty penetrating aqueous solutions and reaching the entire surface of the material. So, when the flow of electrons, that is electric current, is increased to carry out the reaction, there is not enough CO2 to be transformed. But the researchers found that this limitation can be overcome. They have discovered that a certain configuration of ionomers, that is polymers that conduct ions and water to the catalyst, allowed them to considerably increase the ease with which CO2 is distributed along the catalytic surface, thus achieving higher productivity. This ionomer coating contains hydrophobic, that is water repellent, and hydrophilic, that is water attracting parts, and is grouped together to form an ultra thin layer of about 10 nanometers that helps to maintain the reaction where the hydrocarbon is built from the CO2 gas and the hydrogen in the water. About 2 years ago, CO2 electrolysis systems were limited to electrical outputs or currents of tens of milliamps per square centimeter, meaning that only a few molecules of gas can be transformed into something useful. But this new discovery allows them to operate at currents 100 times higher, more than 1 ampere per square centimeter. In this way, many more CO2 molecules can be transformed, reaching activities that were unthinkable a few years ago. Another benefit is that the source of electricity needed for the process can be perfectly renewable, such as solar, wind, or hydraulic energy. So, it is a way of building renewable hydrocarbons.